Let's consider what lenses do. Okay, before going into that, uh, let's go to the simulation. Now here we have an object represented by this arrow here, and at the top of the arrow we have something that illustrates what happens to the light as it is reflected off one point of that arrow, one point of that object. Remember, light is going to be reflected in all directions, and here we are showing just a portion of it. Okay, the portion that's going to point somewhat towards the lens. Now, each one of these light rays, if it's going to pass by the lens, it's going to be refracted. And in being refracted, as you notice here, for a double convex lens, these light rays are going to meet at one point. In meeting at that point, each of the rays is going to support the other rays to form an overall image at this point. Now, every ray is carrying the image at every point, except when a lot of them are going to meet at the particular location, their effects is going to add up, and when I have a lot of beams meeting at that point, then I'm going to have a distinguishable image. And as you notice, there is only a particular point, a particular location where all these beams are meeting. And that's why only at that particular location, that's where we are going to be able to distinguish a neat image. Let's have another look at that, kind of more general look. Let's look at this one here. Now we have the same object, but instead of having just one part of the object reflect light in many directions, I have several parts. A middle part and a lower part, as well as the top part. The colors here are put just to help us distinguish what's what. Notice here that the top, represented by white, it's going to make an image at the top of this image arrow. However, that image arrow is inverted relative to the object. And the middle pinkish purplish light is also represented by a middle light at the formed image. And the bottom yellow is the bottom yellow at the image. So light reflected from one part of the object is going to meet to produce an image of that part. Note here that all of these images are adding up to make an overall image of our object. Now, of course, I could have had multitude of points represented here, except it's going to make the image a little bit difficult to distinguish. Okay, let's simplify the situation and have, instead of light being reflected in all directions, we are taking just the light that's shining parallel to the principal axis. Now, there are a few things I would like you to pay attention to. These light rays are meeting at a particular position. All of them are meeting at a particular position to form for us the image of the object. So the lens is forming an image of the object. Now, actually, I'm not showing in this particular simulation that the different light beams are meeting in the image. We showed it in the previous simulation we looked at. Now, what I would like you to pay attention to is what happens for different positions of the object. We have here markers in this particular simulation. This is of the focal point of the lens, and we see it both sides, and this for twice the focal point. And we have our object here further away than twice the focal point. And observe what we have. Now here, when we get between twice the focal point and the focal point, you see we have a much more enlarged image and further away from the lens. When we go closer to the lens than the focal point, you notice that light is not going to meet here on this side anymore, and we have what's called a virtual image. We are drawing it here in green to show us where it is, but actually light is not going to meet at this part here. Light is going to emerge out of the lens, appearing like it's coming from this image here, from this virtual image. So these are the three different situations. Let's consider how to figure out the positions of the images graphically. The way to do that is to choose some of the light rays that are reflected of the object and follow through these light rays and see where are they going to meet. We usually choose three rays. We call them the principal rays. The first ray is parallel to the principal axis. So the ray is parallel to the principal axis, and then after it passes through the lens, it's going to pass by the focal point of the lens. Okay, let's see it in action. So it is parallel to the principal axis, and then once it goes through the lens, it passes through the focal point. Now, if my object is between twice the focal length and the focal length, we still see the same thing. Now, this is when my object is closer than the focal point. Okay, now that's our first ray. The second principal ray is opposite to the first. So what happens here, if light is passing by the focal point before reaching the lens, when it emerges out of the lens, it's going to come out parallel to the principal axis. Okay, let's look at this. So light passing by the focal point, it emerges parallel to the principal axis. And again, this happens here. For light, now for an object closer than the focal length, light never went through the focal length before reaching the lens. However, the light that would have emerged from the focal length, so you see here it is parallel to the line from the focal length to the lens, light that would have emerged from the focal length, once it passes by the lens, is going to emerge out parallel to the principal axis. Now the third ray is a ray that passes through the center of the lens, and that ray remains unaffected. So a ray moving through the center of the lens remains along the same direction. All rays are going to meet. They're going to meet together at the same point, forming the image we are looking for. Okay, let's look at it. For example, here, see all three rays are meeting here, forming an image of the tip. Now that's, in this case, it's an enlarged image, still inverted, and then in this case, it's a virtual image. They look like they have emerged from that point.